Next, we are going to look at the concept of rate of change. This graph presents data from the World Health Organization on average heights of boys and girls. So here are some questions to think about. What information can you get from this graph? How are the graphs similar? And how are they different? The first thing you might see is that both boys and girls grow at approximately the same rate up until age of 13. We see that the girls' rate of change of height with respect to age slows down, while the boys continue to have a higher rate of change in height up until about age of 15. And then theirs begins to slow down as well. So what is average rate of change? The average rate of change of 2 points is the slope of the line segment joining those 2 points. It can be calculated by taking the delta y and dividing by the delta x, the difference in the y values divided by the difference in the x values. So for example, calculate the average rate of change between each pair of points. For A, we're going to assume that time is x and height is y. So the average rate of change is equal to the change in the y's, so 1400 minus 2000, divided by, going in the same direction, 4 minus 0. Using your calculators, you should get a value of negative 150. So what does this negative 150 mean? This tells you that the height of the airplane is decreasing by an average of 150 meters every minute. Part B. If we want to find the average rate of change, we're going to take the delta y's, so in this case 700 and 400, so 700 minus 400, and divide them by the change in x's, so 400 minus 200. Using our calculator, we see we'll get 1.50, which tells us the cost increases by an average of $1.50 for each kilometer driven. So example 2, the distance required to stop a car depends on the speed at which the car is traveling. So I have the table values here that shows the reaction distance needed to stop a car on drive pavement for given speeds. So here's the speed of the car and the reaction distance needed to stop the car on drive pavement for those speeds. So how do we find the rate? Well, if we want to find the average rate of change, I'm going to take out this first one. We go over to the cell beside it and subtract the one above. Those are what we call the delta y's, so that's 2 minus 0. And then we divide it by the 2x values, which is the speed. That's 10 minus 0. So this gives us, using our calculator, we see we get 0.2 for our average rate of change. And then we can continue from there. Let's go to the next one. We're going to take 4 minus 2, so we go over to the cell beside it. So we get 4 minus 2, and we divide it by 20 minus 10. And again, using our calculators, we will get 0.2. Let's do the next set. So it's going to be 6 minus 4 divided by 30 minus 20, if I subtract those. And again, we get 0.2. Going to the next set, 8 minus 6 divided by 40 minus 30 gives us 0.2. And finally, the last one, 10 minus 8 divided by 50 minus 40 also gives us 0.2. So from the table, we see that the rates of change are constant. So what does that mean about our graph? So let's graph the table values. So for our speeds, we're going from 0 to 50. So I'm going to count by 5s. So there's 10, 20, 30, 40, and 50. And going along The y-axis, I'm going to count by 1, so that's 2, 6, 8, and 10. Next, let's plot our points. 0, 0, 10, 2, 20 and 4, 30 and 6, 40 and 8, and 50 and 10. And notice, since the rates of change are equal, we end up with a straight line. All right, let's try the next one. This table shows the braking distance needed to stop a car on drive pavement for given speeds. Same as above, if I want to find the average rate of change, all I need to do is go over and take the two y values, so 0.5 minus 0, and divide them by the two x values, 10 minus 0. And if I do 0.5 divided by 10, that gives me a rate of change of decimal 0.5. Go to the next one. This is 2 minus 0.5 divided by 20 minus 10. And this gives me a rate of change of 0.15. Let's go to the next set. 4.5 minus 2 divided by 30 minus 20. This gives me 0.25. And then the next one, 8 minus 4.5 divided by 40 minus 30, 0.35, and if you try the last one, and if you continue, the last one will be 0.45. So for this example, we can see the rates of change are increasing. They're getting larger as we move further down the table. So let's graph the data and see what this looks like. I'm going to count by ones along the y-axis. And I'm going to count by fives along the x-axis. So if I want to graph these points, I'm going to start at 0, 0 again. Then it's 10 and 0.5, 20 and 2, 30 and 4.5, 40 and 8, and 50 and 12.5. And if I graph this, you see this graph has a rate of change that's always increasing. So the average rate of change is increasing. The points on the graph do not lie on a straight line. Last example. This table shows the change in height of a tomato plant from germination until the tomato ripens. So again, let's graph this and also determine the average rate of change. So starting with the first set of data, we're going to have 5 minus 0 over 2 minus 0. So we see the rate of change is going to be 2.5. Going to the next one, we have 10 minus 5 over 4 minus 2. So again, we get 2.5. We get 20 minus 10 over 6 minus 4. So we get an average rate of change of 5. And then we'll keep going from there. 40 minus 20 divided by 8 minus 6. Average rate of 10. And then see if you can complete the rest of them yourself. Next, let's graph our data. So now that we have our x and y scale set up, let's plot our points. So our first point is 0, 0. The next one is 2 and 5. And then do the rest yourself. All right, now with the table complete and the graph complete, let's answer the following questions. So first one, determine when the rate of change in height is equal to 0. So we can see in the table the rate of change of height is equal to 0 when we're going from 16 to 18. So that's right here, where we have a horizontal line. So next one, when is it constant? So we have to find where the rate of change remains the same. And it looks like at this point and this point. So if we look at those there, that's this right here. On the graph, look for points that lie along a line, and the rate of change is constant from weeks 0 to 4. And the last one, when is the rate of change changing? Well, that would be for the rest of the graph where it's not 0 and it's not the same. So going all the way from weeks 4 to 16, the rate of change is changing. And the rate of change is changing when the vertical distance between two consecutive points change. So if you look at the rate of change, notice it goes from 5 to 10 to 9 to 2.5 to 5.5 to 2. All those numbers are different, so that is where the rate of change is changing. B, when is the rate of change in height the greatest? So we're either going to look for the steepest line in the graph, or we're going to look for the highest number for the rate of change. And you can see that happens here. So that's between weeks 6 to 8. And the last part, describe the growth of the plant. And looking at both the table and the graph, we can see that the plant grows at a constant rate for the first 4 weeks. The rate of growth increases over the next 4 weeks and then decreases as the plant reaches maturity. After 16 weeks, the plant has reached its full height and the rate of growth is 0. All right, let's summarize what we now know. Identifying rates of change in a table or graph. If the rate of change is 0, you will see that your average rate of change is equal to 0. On a graph, what we would see is a horizontal line. Second, rates of change are constant. That means that your average rate of change for your table are all equal. So on a graph, that would mean that you would have a line that's not horizontal or vertical. And finally, if your average rate of change, or if your rate of change is changing, that means your first differences or your average rate of change, the values in a table are changing, and that could be any type of curve. Please try the following questions.